Hi, in this session we'll discuss about quadrilaterals and the different types of quadrilaterals. So first let us start with what is a quadrilateral. A quadrilateral, you might have seen a shape like this. This is a quadrilateral. It is just a simple closed figure bounded by four line segments. So if I were to take this as A, B, C, D. So there are four vertices. The vertices are A, B, C, and D, and you have four sides A, B, four sides A, B, B, C, C, D, and D, A. And you have four angles. There would be angle A, angle B, angle C, and angle D. And we also would have two diagonals. It is in this two diagonals. The diagonals would be AC and DB. So this is a quadrilateral. Now let us look at what are the different types of quadrilaterals. Let's start first with trapezium. So what is special in a trapezium? A trapezium is a quadrilateral having one and only one pair of parallel sides. So if it is so in this, if I take A, B, C, D as the vertices, B as the vertices, then we can see that AB is parallel to CD. Let's indicate that over here. AB is parallel to CD. And you also see that AD is not parallel to CB. Okay, so this is a trapezium in which one pair of opposite sides are parallel. Now let us look at the second type. The second type is something what we call a parallelogram. Parallelogram. So what is a parallelogram? A parallelogram is a quadrilateral in which both pairs of opposite sides are equal. Okay, let me draw it again. So if you can see, what I have drawn here is what you would call a parallelogram. Let me mark it A, B, C, and D. So in this, the properties that we need to keep in mind are opposite sides are parallel and equal. What is the meaning of that? AB is parallel to CD. Similarly, you have AD parallel to BC. And one more thing that we need to keep in mind, AB is equal to CD and AD is equal to BC. So this is what you call parallel and equal. And one more thing that you need to understand is, suppose if I were to draw these diagonals over here, so I have the diagonals AC and BD. So AC and BD, so diagonals bisect each other. Bisect each other. What is the meaning of the word bisect? It means dividing equally into two parts. Dividing equally. It is not just dividing, it is dividing into two equal parts. That is, suppose I have the diagonal AC. Now BD cuts AC at O. And what happens here? You'll find that AO equals OC. They are both equal to each other. Similarly, DB is also bisected by AC, and so in the case of when I look at DB, I can see that DO is equal to OB. Okay, and these are the key things that you need to keep in mind. Now the next type of shape is rhombus. Now rhombus is a quadrilateral, but rhombus is a type of parallelogram because it has all the properties of a parallelogram. What are the properties of parallelogram? Opposite sides are parallel and equal, both the pairs, and the diagonals bisect each other. In rhombus, what is the speciality is that all the sides are equal. Suppose I have A, B, C, D, and I have these diagonals over here. Now, as we had put earlier, AB is parallel to CD, AD is parallel to BC, AB equals CD, AD equals BC, and if I take this point of intersection O, AO equals OC, BO equals OD, and another thing to note here is AB equal to BC equal to CD equal to DA. All these four sides are equal. Well, if I take A as one of the sides, then the total all the sides are equal to each other and all of them become A. And so the properties that you need to keep in mind are opposite sides are parallel. So let me list out it again. Opposite sides parallel. Second, all sides equal. It is not just opposite sides. All sides are equal. That is a speciality over here. Then opposite angles are also equal. Even in parallelogram, that is something that I missed telling you. Angle. So let me put that as a third point. Opposite angles equal. That means angle A equal to angle C and angle B equal angle D. This is something that you need to keep in mind. So similarly, I can write it over here. Opposite angles are equal. Now, what is the next one? Yes, you got it right. Diagonals bisect each other. But there is something unique about this. it doesn't bisect each other at any angle. It bisects at 90 degrees. They bisect each other perpendicularly. So bisect each other at right angles. So I hope you understood that. So this is the difference in a parallelogram. They bisect, and if you look at the angles over here, this angle would be equal to this, and this angle would be equal to this angle. That is, angle DOA equals BOC, and DOC equals BOA. So these two would be equal, but here they are equal. Not just those two are opposite angles are equal. All the four angles are equal, and all the four are 90 degrees. So they bisect each other at right angles. That is one point that you need to keep in mind. Now, the next shape is a shape that all of us know very well. It is a rectangle. So, rectangle is also a parallelogram in which every angle is a right angle. So, this is 90, this is 90, 90, 90. So, all the four angles are 90 degree in a rectangle. So a parallelogram in which all the four angles are equal would become a rectangle. So here too you can easily see that AB is equal to CD and BC equals AD, and AB parallel to CD, AD is parallel to BC. All four angles, angle A equals angle B equals angle C equals angle D, they're all 90 degrees. Okay, so if I want to write the properties, opposite sides, parallel and equal. Second would be all angles equal, it is equal to 90 degree. Third would be I have not drawn and shown it here, the diagonals bisect each other, that is as we have seen it in the parallelogram. But the interesting thing here is diagonals are equal. Diagonals are equal. So in a rectangle, diagonals are equal and also bisect each other, but they don't bisect each other at 90 degrees. That is something you need to keep in mind. That is very special for rhombus. Now let us go on to the next shape. The next shape that we will take is a square. So what all did we finish? For the fifth one is square. A, B, C, D. So a square has all the properties of a rectangle, and a couple of things extra. So a square is just a parallelogram in which all sides are equal and each angle is a right angle. So these are right angles. So all sides are also equal here. So sides equal. So that means AB equals BC equals CD equal DA. Then the angles are 90 degree. They're all equal and they are 90 degree. Then another interesting thing about this is, just as in rectangle, diagonals are equal, and as we have seen in a rhombus, they bisect each other at right angles, and they bisect each other at right angles. That is, here it's 90, 90, 90 and 90. Okay, so they bisect each other at right angle. Now, with this, I think you understood the relationship between rectangle, square, rhombus, parallelogram, trapezium, and also the small differences that are there between each of them, and some of the properties which are same in all of them. And all of these are parallelograms. That's what you need to keep in mind. Now, the next one I want to tell you is new one called kite. So kite is not a parallelogram. Kite is also a quadrilateral with two pairs of equal adjacent sides but unequal opposite sides. What do I mean by this? Let me draw it and show it. Somehow doesn't seem to be picking it up properly. Let me just draw it roughly and keep it like that. So just bear with me. Yeah. Now let's look at this figure that I have drawn. Now let me name it as A, B, C and D. When you look at this figure, I can see DC is equal to BC and AD equals AB. So two pairs of equal adjacent sides. So that's the first property. Two pairs of equal adjacent sides. It is not opposite sides, it is adjacent sides. Adjacent sides means next to each other. So CD and BC, they are adjacent. AD, AB, they are adjacent. So BC equals DC and AD equals AB. So two pairs of equal adjacent sides. Now the second point that you need to keep in mind is unequal opposite sides. Unequal opposite sides. Now unequal opposite sides, it's very clear here. CD is not equal to AB. AD is not equal to CB. Another thing that we need to note, if I draw the diagonals, if I see here DBC is a isosceles triangle. If you look at it, because DC equals BC, so it is an isosceles triangle. Triangle is isosceles. Now I have, if I take triangle DAB, so here for both of them the base is common, DB. So here too DAB is isosceles. So in these two triangles, this common base is bisected by the other diagonal. So DB one of the diagonals which serves as a common base for the two isosceles triangles gets bisected. So DO equals OB. And also these two diagonals are perpendicular to each other. You need to note that CO is not equal to OA, but only DO is equal to OB. And this DB line is a common base if I were to split it into two isosceles triangles. I hope you have understood the basics of the different shapes of quadrilaterals. If you have any doubts, you can get back to me. And in the coming sessions, I will be discussing some problems using these properties that we will be solving. Thank you.